So we have a nice little experiment today involving indicators for acid-base reactions. The basic idea of an indicator is that it is a weak acid. Therefore, it has a Ka. It is in equilibrium. When the solution is very acidic, the indicator will all be one color. But as the pH of the solution increases, the amount of protons in solution goes down, the equilibrium will shift over to the other indicator's color when it loses its proton. And so this equilibrium depends on how acidic the solution is. What we have in the laboratory is a solution of 1 molar HCl. In that extremely acidic solution, the indicator is all going to be in its protonated form. That is, there will be very little of the ionic form of it present in solution. You will then put the indicator into 5 solutions, one of which is a phosphoric acid buffer. It has a pH of about 2.2. One is an acetic acid buffer, which has a pH of about 4.6. The next will be a dihydrogen phosphate buffer, which has a pH of about 7.2. Then there'll be an ammonium buffer, which has a pH of about 9.3. And finally, our last solution is a 10th molar solution of sodium hydroxide, and that has a pH of about 13. In that form, the indicator is entirely in its deprotonated form. So whatever color it has in the sodium hydroxide solution is its totally deprotonated form. Whatever color it has in the 1 molar HCl solution is absolutely its protonated form. Somewhere between a pH of 0 and a pH of 13, the equilibrium will shift, and you will go from that original 1 molar HCl color to whatever color it has in the sodium hydroxide. And the question is, over what pH range approximately is that color taking place? Because we have said it takes about a change of about 2 pH units to cause the indicator to change. You're going to be trying a number of indicators, and the point of the experiment is you need to order those indicators in the order, the one that changes color in the most acidic solution to the one that changes color in the most basic solution. The 6 indicators we're going to be testing today are metacreosote purple, phenolphthalein, crystal violet, bromophenol blue, azurine yellow R, and methyl red. One of the things you're going to have to pay attention to, since you're looking at color changes, is to make sure you're actually getting different colors. If a yellow solution turns into a blue solution, that's clearly a color change. But if a yellow solution turns into a green solution and then turns into a blue solution in the next solution, is that actually 2 color changes? And the answer, of course, is no. What simply happened is the color change is yellow to blue, but the pH of the buffer you caught actually was in the middle of that change for that indicator, and so you saw a combination of the yellow and blue color giving you the green. So this is something to pay attention to. You're looking for clearer color changes. If there's a sort of kind of color change between 2 of them, it might be that you actually caught that indicator in a transition. And therefore, you're not seeing several color changes, you're seeing one slow color change. The other thing you have to consider is some indicators are polyprotic. That is, they don't change once in going from 0 to pH 13, they change twice. And if you have an indicator that changes color twice, you're going to have to put it in your rank 2 times. For the first time it changes color, and for the second time it changes color. You're going to have to go to Blackbaud and download the lab sheet for this experiment. It's on Blackbaud, and then you're going to be able to fill in the data as you collect it. The indicator we're going to be testing now is known as meta-creosote purple. We add a couple of drops of the indicator to each of our solutions. And see what colors they have. And there are the colors of meta-creosote purple in our different pHs. We're now going to test phenolphthalein in each of our 6 solutions. And there are the colors of our phenolphthalein in our 6 different solutions. We'll now try the brome phenyl blue in each of our solutions. And so that is the brome phenyl blue in each of our solutions. We're now going to try the alizarin yellow R in each of our 6 solutions. And there is our Alzilon yellow R in our 6 solutions. We'll now try the indicator known as crystal violet in each of our 6 solutions. And so there is the color of crystal violet in each of our 6 solutions. We're now going to see what the indicator methyl red looks like in each of our 6 solutions. And so we see what methyl red looks like in our 6 solutions. So now you've collected all your data, and you've seen the color changes in all the different solutions. And you should be able to rank the indicators from the one that changes in the most acidic solution to the one that changes only in absolutely basic solution. And that's it for the experiment. Have a nice day.